Now consider the cantilever beam with UDL load. So in the last session we are considering the cantilever with point load. Here we are considering cantilever beam with UDL load. So this is the cantilever beam, this is the UDL. UDL is nothing but uniformly distributed load. Uniformly distributed load is nothing but the load at any section or portion of this load section is same. So this is the UDL. Consider W kilonewton per meter. So this is the intensity of UDL and distance is L. So here the variation of shear force and bending moment due to the UDL is linear and variation of shear force due to this UDL is linear and bending moment is parabolic, 2-degree parabolic. So what is the shear force value at A and B? It is the A and it is the B. So first of all calculate shear force values at A. At A, shear force value at A is 0 because of there is the no load. The intensity of load at B is B is 0. In the same way at A, consider at A the shear force is nothing but this total load. The total load is nothing but W. This is the shear force at A. It is in kilonewton meter, but shear force is in kilonewton, so that we are multiply with distance, then it will converted into kilonewtons. Is nothing but shear force. So this W will multiply with portion of load. Portion of load is nothing but acted portion of load. Acted portion is here L. So W into L. So shear force at A is called W into L. This is the shear force values at B and A. Next, bending moment values. So at B, we know already shear force bending moment at free end of the cantilever beam is 0. In the same way at A is nothing but force into perpendicular distance. At A, what is the force? This is the force. Force is nothing but intensity of UDL into acted distance. So that is the force into perpendicular distance. Perpendicular is nothing but the shear the force due to the UDL force is converted into point load. That point load will be acted at the centroidal distance of that UDL. So this is the portion of UDL. So this UDL converted into point load. That point load will act at the distance of centroid of this load. So centroid of this load is nothing but L by 2. So the converted point load will be acted here at centroidal distance. So the perpendicular distance between these two is nothing but L by 2. So here, see here. So first initially to convert the UDL into point load. So UDL will be converted into point load by multiplying with distance. So W into L. This is the point load, and the perpendicular distance is nothing but the converted point load will be acted at the center of this UDL, and distance is nothing but from this center to A. So from here to here is nothing but L by 2. So L by 2. Perpendicular distance is L by 2. So total UDL is nothing but WL square by 2. So this is the bending moment at A. This is the shear force and bending moment diagram. Shear force and bending moment values. So now draw shear force and bending moment diagram. So this is the baseline. and shear force at B is 0 and shear force at A is W into L. This is the shear force. Shear force diagram. Here intensity is W into L. In the same way, draw bending moment diagram. So bending moment at free end is 0 and bending moment at A is WL square by 2. Here WL square by 2. So the variation of shear bending moment diagram is parabolic. So this is the 2 degree second degree parabola. This is the BMD bending moment diagram. These are the shear force and bending moment diagram for the UDL on the cantilever beam. In the same way, consider. So in this diagram you should remember the intensity variation of shear force diagram. Here linear variation, here parabolic variation. These are the two important points while drawing of shear force and bending moment diagram with UDL for any type of beam where the UDL is acted. The variation of shear force and bending moment diagram will be like this, linear and parabola. These are the important points. So next, consider cantilever beam, UDL with point load. So these are the now take some numerical value of intensity. This is the 10 kilonewton meter and this is the, for suppose take 5 kilonewtons and their distances are, take this is the 5 meters and this is 2 meters. This is the cantilever beam and these are the intensity of, this is the point load and this is the UDL. So now give annotation A, B, C. So now calculate shear force and shear force values. So yes, SF at C is, here we have some intensity at C, but here nothing, there is a no intensity. This is the UDL at point is negligible intensity. For that we are taken 0 value, 0 here, but here at exactly point C there we have some intensity of load, that is nothing but 5 kilonewtons. 5 kilonewtons. We know already what is that section, what is the your sign, already you know. So this is the shear force at C. Next, SF at B. SF at B is nothing but, here just right of the section, this is UDL is negligible, but we have 5 kilonewtons. So at SF at B is positive 5 kilonewtons. In the same way, SF at A. So at SF at A, so section at right of the A is this is all, and intensity of loads is 0.5 kilonewtons, sorry 5 kilonewtons plus this is the load. We already know conversion of UDL into point load. This is the UDL converted by multiplying with distance. So here we have UDL is 10 kilonewtons and acted intensity is 5 meters. So this is the point load conversion. So intensity is 55 kilonewton at A. This is the shear force value at A. In the same way, next bending moment values. Bending moment values at points. Bending moment values at different points. Here at point C, bending moment is 0 because of we have load, but there is a no perpendicular distance between the load and considered point, so bending moment is 0. And also we know the bending moment at the free end of the cantilever beam is 0. This is the bending moment at point C. In the same way, bending moment at B is here B. So force into perpendicular distance, it is the clockwise direction. So positive 5 kilonewtons into perpendicular distance is 2 kilonewtons, sorry 2 meters. So bending moment is positive 10 kilonewton meter. This is the bending moment at B. And next, bending moment at A. So at bending moment at A, what are the forces is 5, 10 and their distances are 5, 2. So here plus 5 into perpendicular distance is from C to A is 2 into 2, sorry 2 plus 5. 2 plus 5 is nothing but 7. So 5 into 7 plus here the point load is nothing but 10 into 5, and this point load will be acted at the middle or central portion of the UDL. At central portion of the UDL is nothing but here the distance is 2.5 meters, half of the 5 meters, so 2.5 meters. It is acted at distance of perpendicular distance is 2.5 meters. 2.5 meters. So total intensity is the 7 5 is 35. So 50 plus 50, so 25 into 5 is 125. 125 plus 35, 170 over, sorry 160 kilonewton meter. This is the variation of bending moment along, this is the variation of bending moment values along the length of the beam. So draw shear force and bending moment diagram for the calculated values. So initially draw baseline. At shear force value at C is 5 kilonewtons. At B also 5 kilonewtons. So there is no variation between B and C. So at A is 55 kilonewtons at A here. So between, due to this UDL load, the variation of shear force will be linear. So this is the variation of shear force. This is the shear force diagram. This is the SFD. In the same way, draw bending moment diagram. This is the bending moment, this is the baseline, and bending moment at C is 0, and bending moment at B, here B is, what is the bending moment at B? 35 plus 50, 85 kilonewton meter. So here 85 kilonewton meter. So between these two loads, variation is linear. And at A, bending moment is 160 kilonewton meter. So here 160 kilonewton meter. So variation is parabolic variation, 2-degree parabola, due to the UDL load. This is the variation of bending moment along the length of the beam. This is the bending moment diagram. Here 85 kilonewton meter, here 0, here 160. If there is any mistake, please calculate. So 160, 85, 0, 5 and 5, and here 55 kilonewton shear force. These are the variation of shear force and bending moment diagram for UDL and point load. So these are the two diagrams. Thank you.